Namaskar friends, welcome to session 39 in our course on work system design, and we are currently in 8th week of our discussion, and the focus of the discussion now has shifted to work measurement from method study. In the last 4 weeks we have discussed on method study and we have tried to develop one best method of doing the work, and now we need to understand that and how much time that work must be accomplished using the standard procedure or the standard sequence of operations which has been identified during the method study. And in work measurement, this is the 4th session today, and we are trying to introduce the concept or understand the concept of work measurement or time study. And if you remember, in the very first session we had the basic concept that what are the advantages of doing the work measurement or setting the standard times, what are the objectives, what we can gain, how it can help us in decision making. Then we have tried to see what are the various techniques such as stopwatch time study, synthetic data, PMTS, that is predetermined motion time system, or one of the examples we have seen method time measurement, MTM. Then we have also studied the analytical approach as well as the historical viewpoint of finding out the standard time. So there are standard techniques which we have already introduced. I am saying introduced because right now we just know the names of these techniques. We have to further study in detail that how this technique operates, what are the specific application area for individual technique, what type of time standards we can set using these techniques, what are the types of focus areas, repetitive, non-repetitive, homogeneous, heterogeneous type of work, where which technique is applicable, that also we will understand when we focus on each and every technique. In the last session, that is session number 38, our focus primarily was to understand that what are the steps involved, but because the sessions are scheduled for 30 minutes only, we were not able to complete the steps involved. So in session 38 we have seen the steps involved, but we were able to cover the 4 important steps. And as I have already highlighted, that most important part is to identify, to select the work on which you want to set your time standard. That there may be lot of work happening in the organization. You may have time standards for some particular work elements. You need to identify what are the other work elements, or we need to retime these work elements that are already being timed or that have already been timed. So that is very important to identify, select, define that what you want to do when you are doing your time study, what is the work you are going to focus when you are doing your time study. So that we have focused in the previous session, and we have seen once we have identified that this is the focus area, we want to find out the time standard for this particular work being done, or this particular specific department or section need to be investigated. Always there is overtime coming from this particular section, so let us see how they are doing the work. Can there be some improvement? Can we set some time standard for each and every element of work being conducted in this section or department? So once after identification or identifying a specific department or a type of work that we need to do the time study for, we will record all possible information related to that. The information can be related to the way the work is being done, the work that is being done, the operator he or she who is doing the work, the working environments available or prevailing for during the work being completed. So we have to get all possible information related to that work. Then what we need to do, we have taken an example of stitching of a shirt, that we can divide the total work of stitching a shirt into the individual elements. Why do we need to divide the work into the individual elements? That we have also seen in the previous session. We have seen that it is better to investigate the individual work elements rather than in totality. Secondly, it will help us to differentiate between the effective and the ineffective time. Also we can micromanage the operation. We can see that which element is a high fatigue element, where the worker gets fatigued. So when we divide the work into the individual elements, it is easier to comprehend as well as analyze. Then we have seen for each element we need to record the time. How will we record? We will record using the stopwatch, and that stopwatch time study is one of the important direct measurement techniques under work measurement. And we have seen that we can have a cumulative recording, and then we can subtract the time for individual element, or we can have another method in which we will directly measure the time, so which is a direct measurement of the time for particular element or for each element of the work. So with there we end. We have concluded our discussion in the session number 38. So today we again start from the discussion that we have left in the session 38. The first part is, let us see now, the first part is the selection. The first part is the selection of the work to be studied and defining the objective of the study. This is the first part which we have already covered. Second is obtain and record all information. Now this information may be related to the work being investigated, it may be related to the worker, or it may be related to the conditions or the working conditions. So we have to obtain and record all possible information related to the work being done, the worker who is doing the work, and the working conditions. Then we have to break down the operation into the individual elements. Why? That we have already understood in our previous session. Then we have to measure the time. How? Maybe one of the techniques can be stopwatch. There are different types of stopwatches we will see in today's session. So once we have measured the time, what we need to do? Then we come to step number 5. Extend the observed time into the normal time. So whatever we have observed using the stopwatch, we need to extend it into the normal time. So maybe these definitions we will again try to understand. Observed time, what is the observed time? Normal time, what is the normal time? But today we are just trying to understand the steps involved. So first we have to measure, we have to find out the time for each and every element, and then we have to convert that observed time into the normal time. How it will be done? Assess the operator's effective speed of work relative to the observed concept of normal speed. So here there is a ratio coming into picture. Assess the operator's effective speed. The operator will be working at a particular speed. He is performing a task. Maybe he is making 10 components per hour or 20 components per 2 hours. So that is the speed at which the worker is working. Then there is a concept of a normal speed. Now what is normal? Suppose I am the time study analyst. I may feel that 50 components per hour is the normal speed at which a worker must operate. So that is normal from my point of view, but the worker is producing 10 components per hour. I wish that a worker must produce 15 components per hour. So as a time study analyst, for me the concept of normal speed is 15, but the worker is performing, he is doing only 10, so he is slightly slow. So this is called the performance rating. We will discuss performance rating in detail because it is a very important concept, and what do we mean by performance rating, that we will see. But for today you can just remember that we have to rate the worker or the rate at which the worker is performing the task in context or in relation to a normal rate at which a able-bodied person who is suitably qualified and who is suitably skilled must work. So there is a concept of normal rate of working, and in relation to that we have to rate the worker whether he is slow or he is fast. So based on the observed time we will try to convert it into the normal time using the performance rating. How it is done? It is given here. We will calculate the normal time from the observed time by multiplying it by the rating factor. Now what is the rating factor? We will try to understand it during the performance rating, our session on performance rating, that is session number 14. So adjust the observed time by rating factor to obtain the normal time for each element. So it is slightly skipped here. This is the normal time for each element. So we will calculate the normal time. Observed time directly we have taken by direct measurement using the stopwatch. We are multiplying it by the rating factor. What is the rating factor? It is the rate at which the person is working in context of or in relation to the normal rate of working. Now calculate the normal time for whole operation, because we are doing this for one element. So we are calculating the normal time for each element. Now for whole operation, how we will get? By adding the normal time for various element. So for each element we will add the normal time and we will get the normal time for the complete operation. So the normal time, if we can write, for the complete operation will be the normal time for element 1 plus normal time for element 2 plus maybe it has 5 elements, normal time for element 5. So if there are 5 elements, so this way we can very easily calculate the normal time for the complete operation. So again I am reading it for you. Calculate the normal time for the whole operation by adding the normal times of its various elements. Now next step is add the suitable allowances. Now what are these allowances? This will also come up in our further discussion. Now add the suitable allowances to compensate for fatigue, personal needs, contingencies, etc., maybe miscellaneous, to give standard time for each element. So we have calculated the normal time for each element from the observed time that we have recorded. Now from the normal time we are adding the allowances. The allowances can be the fatigue allowance, the personal allowance, the contingencies, miscellaneous allowances, to give the standard time for each element. Now standard time for each element we have got, but we want the standard time for the whole or the complete operation. Now compute the allowed time for the entire job by adding the elemental standard times considering the frequency of occurrence of each element. Now for each element we have found out the standard time, so we can compute for the entire job by adding the standard time calculated for each element. So if there are 5 elements, we will add the standard time for all the 5 elements and calculate the standard time for the entire job. And if some element the frequency is more, it will be multiplied accordingly in order to find out the standard time for the complete job. Now the last part is, you have already calculated the standard time. Make a detailed job description describing the method for which the standard time is to be established. So the method is very important, because you have found out the time based on the sequence of work elements. So if the work element sequence is disturbed or there is change in the method, the time standard will not hold good. So it is very important to make a detailed job description describing the method for which the standard time is to be established or has been established, and then test and review the standards wherever necessary. So this is the overall summary of the steps involved in timing or in work measurement or in time study. So we can very easily summarize that if we follow the systematic approach, we can very easily find out the standard time for performing a operation or for performing a job. Now what are these steps? Already we have revised today, so we can again maybe focus on the broad areas. So the broad areas are, first is select and define the work that you want to perform or that you want to set the time standard for, or for which you want to set the standard time. So after defining, you have to record, observe all the information, or observe and record all the information possible. So after recording, you can break down the work into the individual elements. After breaking down, you can measure the time taken for each element using the stopwatch. After you have found out the observed time, it has to be multiplied by the rating factor. What is the rating factor? It is the speed at which the worker is working in relation to the normal speed at which a worker must work. After multiplying the observed time with the rating factor, we get the normal time, and the normal time for each element is added to calculate the in order to calculate the normal time for the complete operation. So when you know the normal time for the complete operation, you can add allowances to that. There are different types of allowances like fatigue allowance, there can be a miscellaneous allowances. So when you add all these allowances to the normal time, you will get the standard time for each element, and then for each, the standard time for each element is added up to calculate the standard time for the entire job. And then you have to put a complete description of the sequence of elements or the standard method which has been used for doing the work for which the time standard has been set, and finally you have to test and review the standards wherever necessary. So this is the complete sequence of finding out the standard time for a given job. After this, now we will quickly have a overview of the time study equipment, because it is fairly standard and every maybe year or two there are so many changes related to the technology, and when the technology changes, the equipment that we use also changes or also change, and therefore we are just going to have a 10 to 12 minutes overview of the different types of equipment that we use, because if we go and perform a time study ourselves, how to use the equipment we must know. So this is going to give you a brief overview only of the equipment that is used for conducting the time study. Now time study equipment, now first of all just revise what is time study. Time study is a work measurement technique for recording the times of performing a certain specific job, very important, or its elements carried out under specified conditions, and for analyzing the data so as to obtain the time necessary for an operator to carry it out at a defined rate of performance. So there is no need to get confused with this long definition. If you break down the definition into individual words, you will be able to understand. Rate of performance, now I think you have little bit of idea about this thing. Then specified job, there has to be a standard method of doing the job, or the various we can find out the time or recording the times of performing a certain specific job or its element, which we have seen in the steps that sometimes we divide the total work into its element, carried out under specific conditions, which we have already recorded during the second step of our time study, that we need to record all the information related to the working conditions, and then we analyze the data. We are doing some mathematical multiplications and additions in order to setting up of the standard time. If you have seen the various steps involved, we multiply the observed time with the rating factor, then to the normal time we add, we perform a additive operation of the allowances in order to find out the standard time. So therefore we analyze the data so as to obtain the time necessary for an operator to carry it out at the defined rate of performance. Rate of performance also you know. So this is the basic summary. Some of the diagrams like a camera is shown here, stopwatches are shown. Now what are the time study equipment? The basic time study equipment consists of a stopwatch or study board and time study form. So this is very basic necessary equipment that is required for performing the time study. Other time study equipments are motion picture camera, electrical and mechanical time recorders, electronic data record collectors. So there can be advanced equipment, even advanced than what is listed on your screen. Now let us see what is a stopwatch. Stopwatch is the measuring instrument to observe the elemental timings, and usually a decimal watch is used. So the classification is given. This is from the standard book Introduction to Work Study by ILO. So stopwatch is, it can be of electronic type, it can be mechanical type. Within mechanical it can be flyback and non-flyback, or it can be split hand. This flyback we have already seen in our previous session. Then electronic can be standalone stopwatch or a electronic study board. So we can have different types of stopwatches. Now what is the mechanical type of stopwatch? Mechanical type watches may be obtained with any one of the three graduated scales. So we will see one of the examples of the scale, but there can be different types of graduations. Now why different types of stopwatches? If you remember in method study we have seen that we may do a broad observation and prepare a outline or operation process chart, or we can go to the micro motion, divide the work into grasp, move, transport empty, transport. So we can do a micro motion analysis or the motion of the study of the motions of the body or the basic motions of the body, or we can do the complete analysis of the movement of material in the shop floor. So the level of analysis may be different, and therefore depending upon the requirement we have different types of stopwatches and which can record time up to different levels. So recording 1 minute per revolution by intervals of 1/5 of a second with a small hand recording 30 minutes. We will see one example of the watch. So here intervals of 1/5 of a second are also recorded. Recording 1 minute per revolution calibrated in 1/100th of a minute. So 1/100th of a minute is calibrated on the scale, which is small hand recording 30 minutes at the decimal minute watch. So you can have two hands, maybe a bigger hand and a smaller hand with a small hand recording 30 minutes. Let us first see the watch. This is the watch you can see. So there is a smaller watch, smaller indicator inside and a bigger graduation here. So this is the difference between the discussion that we are doing here. Small hand recording 30 minutes, which means the inner hand may record 30 minutes, the outer hand will have a different graduations, 1/100th of a minute. Recording 1/100th of an hour per revolution calibrated in 1/10,000th of an hour, the small hand records up to 1 hour in 100 division. So that also is possible. So there here you can see a flyback decimal minute stopwatch. It is written here a decimal minute stopwatch, which we have already used this word, the decimal minute watch, the decimal hour watch. So here you can see this A and B are also equally important. What is A? It is clarified here. A means slide for stopping and starting the movement. So we can start the stopwatch from this A and we can stop it. And what is B? It is given here. B is, it is a winding knob. Pressure on this knob returns both hands to 0. So this is hand 1, this is hand 2. So if we press this knob B, both will come to the 0 position. So this is the way we can operate the stopwatch. So a flyback decimal minute stopwatch, probably the type is most generally used, is shown in the figure. The hand of the small dial makes 1/30th of a revolution for each revolution of the main hand. So for the each revolution of the main hand, the inner hand, this one which is in the inner dial, makes 1/30th of the revolution, which means that it makes a complete turn after every 30 minutes. So this is going, it is shown, this is 30. So one rotation of this inner hand will give you 30 minutes. Stopwatch flyback type. In this type of watch, the movement is started and stopped by a slide A at the side of the winding knob B. Pressure on the top of the winding knob causes both the hands to fly back to 0 without stopping the mechanism, from which point they immediately move forward again. If the slide is used, the hands can be stopped at any point on the dial and restarted without returning to 0 as soon as the slide is released. So what is the slide? It is shown here. The movement is started and stopped by a slide. So this slide is being referred back again here, that if the slide is used, the hands can be stopped at any point on the dial and restarted without returning to 0. If you want to return to 0, then you have to use the winding knob, which is given here. Pressure on the top of the winding knob causes both the hands to fly back to 0 without stopping the mechanism, from which point they immediately move forward again. This type of watch can be used for either flyback or cumulative timing. And if you refer back to the previous session, we have already differentiated between the two. What is the difference between the flyback and the cumulative timing? In cumulative, we start at the start of the first element and end at the end of the work cycle, and then with cumulative subtractions we try to calculate the time for each and every element, whereas in flyback we can directly record the time for every element without the need of a subtraction after the completion of the cycle. Now non-flyback type of watches are also there. The non-flyback type is controlled by pressure on the top of the winding knob. The first pressure starts the watch, the second pressure stops it, and third pressure returns the hand to 0. So in flyback type of watches, stopwatches, we have seen there are two A and B control mechanisms, but here there is one. The non-flyback type is controlled by pressure on the top of the winding knob. The first pressure starts, the second pressure stops, and third pressure returns the hands to 0. This watch is suitable only for cumulative timing. So we have seen cumulative and in previous case flyback timing, but here this non-flyback watch is used for cumulative timing only. Now the conclusion for the stopwatch, we can see that whatever type of watch is used, it should always be remembered that it is a delicate instrument which must be treated with care. Watches should be wound fully before each study and should be allowed to run down overnight. At regular intervals, they must be sent to a watchmaker for cleaning and routine overhaul. So this sums up that regarding the maintenance and the proper use of the watches, that what are the safety precautions for the stopwatches. Then we use the time study board. The study board is simply a flat board, usually of plywood or any suitable plastic sheet, needed for placing the time study forms. Now what are these time study forms? We will take one example. It is a board like this on which we place our time study form. It should be rigid and larger than the largest form likely to be used. It may have a fitting to hold the watch. So you can hold the watch also on the time study board, so that the hands of the work study person are relatively free and the watch is in a position to be read easily. So on the board you can have a facility for putting up a time study form, and you can also may have a facility for putting the watch also on the time study board only. For a right-handed people, the watch is normally placed at the top of the board on the right hand side, and the forefinger or the middle finger of the left hand used to press the winding knob when resetting the watch. So you can put it, suppose I am right-handed, it can be put here, and left hand can be used to, as it is given here, the forefinger or the middle finger of the left hand used to press the winding knob. This is one example. You can see this is the stopwatch, this is the board, this is the stopwatch, this is the board. So you can see, you can have for this is a general purpose, and maybe here this is for a short cycle form, because quickly you need to change it again and again. Some work study persons prefer to attach their watches with strong rubber bands or leather thongs around the two middle fingers of their left hand. So sometimes you would like to hold the watch in your hand also. So some work study persons prefer to attach their watches with the strong rubber bands or leather thongs around the two middle fingers of their left hands, and to hold them at the top of the board in that way. So they may keep the watch like this, hold the watch like this, and they can operate also. A strong spring clip should also be fitted to the board to hold the forms on which the study is recorded, as we do in our engineering graphics classes when we make drawing sheets. A study board which is either too short or too long for the study person's arm soon becomes tiring to use. So the size of the board must also be taken into account. Now these are the electronic stopwatches and study boards. An electronic stopwatch performs exactly the same role as a mechanical one, the recording of the element duration. So what is our purpose of using the stopwatch? To record the duration of time, or to record the time taken for individual elements of the work being done. One of the main advantages is that it allows flyback timing to be performed without any loss of accuracy. So it allows flyback timing, maybe direct timing can be done without any loss of accuracy, so it means that the digital watches are slightly more accurate as compared to the other types of stopwatches. Now time study forms, quickly we can see what are the different types of time study form. Only one example we will take. So time study forms are usually printed forms of standard size. The use of standard forms is desirable as the constant information such as part number, part name, operation printed on the operation description, observer's name. So what all can be there, we can see with the help of the form. We will go to the forms. You can see this is one of the time study form. What is written here? The name of the department can be there, operation, what is the operation being done? Maybe it can be related to drilling of a hole, or maybe machining of a machining on a lathe machine of a shaft, or whatever can be the operation. Then plant and machine operation, machine department, tools and gauges used. Then the product, drawing number can also be there, the quality required can be there, material can be there, study number, sheet number, time off, time on, time off, elapsed time. So operative, all details are available. Then the element description, what are the elements for which we are finding out the time. Then the rating, as we have seen, performance rating. This is watch reading, subtracted time, basic time or the observed time. Again the element description here. So this is one of the standard types of time study forms which is used for recording the times or the durations taken for the various elements for performing the task. So coming back to the time study forms. So time study forms are usually printed forms of standard sizes. The use of standard forms is desirable as the constant information which we have already seen, such as a part number, part name, operation description, observer's name, other descriptions are printed on the top of the form, which eliminates the possibility of any details being missed. So we want to put all possible details information on the form. As the size of the forms are standardized, they can be easily filed for future referencing. So there can be other types of time study forms also, but one of the forms I have tried to introduce, that what all information we need to put in the time study form, and we have tried to see the three important types of equipment that are required for conducting the time study. Now these equipment are the stopwatches. There are different types of stopwatches available. Then we have also seen the time study board and the time study forms. Also we have tried to complete our discussion which we started in the previous session regarding the steps involved in the work measurement or time study. So with this I conclude the today's session. There was another description which I have tried to highlight today, that in future we will be talking about the allowances. We will be talking about each of the techniques that are used for finding out the standard time for the various types of work being done in the organization. Thank you.